Alright guys, today I'm going to take you through the Day 3 warm-up and notes. Let's start with a little review. How do you find these features of a rational function? To find a vertical asymptote, that's when you're going to set the denominator equal to 0 and solve for x. You're going to end up with something like x equals some number. To find a horizontal asymptote, you do not set the numerator equal to 0. This is where you have to think about your cases. You may have the case that y equals 0 if there are 0 x's on top, or you may have y equals the ratio of the leading coefficients a over c if you have the same number of x's on the top and bottom. The x-intercept, or the zeros, is where you're actually going to set the numerator equal to 0. To find the y-intercept, you're going to plug in 0 for x. And to find the wholes, this is where you set the eliminated factor equal to 0. Okay, so let's practice some of this, just finding specific things, not doing a full-out graph. So the first one, they want us to find the vertical asymptote. So we're just going to set the denominator equal to 0, and we're going to get x equals 3. For number 2, they want us to find the horizontal asymptote. This is where we think about the degrees in the numerator and denominator. Since they have the same degree, we're going to take the ratio of their coefficients and get y equals 2 over 3. For number 3, they're asking us to find the zeros. This is where you're going to set the numerator equal to 0. So if 2x plus 1 equals 0, we subtract the 1, and we're going to get negative 1/2. For number 4, they're asking us to find the y-intercept. This is when you plug in 0 for x. So 0 plus 2 over 0 minus 6, 2 over negative 6 reduces to negative 1/3. Number 5 is asking us to find wholes. So this is one where we're going to have to factor first. The top is going to factor x minus 4, x minus 3, and the bottom is going to factor x minus 4, x plus 2. So the factor that's going to be eliminated is the x minus 4. When we set that equal to 0, we get x equals 4. So the whole is going to happen at 4 comma something. To get the something, we have to plug 4 into the new equation, which is x minus 3 over x plus 2. When we plug that in, 4 minus 3 over 4 plus 2, we get 1 over 6. So the whole is going to happen at 4 comma 1 over 6. Number 6 is asking us to find the vertical asymptote. This is where we would set the denominator equal to 0. Before we do that, we need to factor. So if I factor the denominator, I'm going to get x minus 5, x plus 2, and then I can see that the x plus 2's actually cancel out. The only thing I have left in the denominator is x minus 5. If I set that equal to 0, I get x equals 5. At x plus 2, I would have a whole at negative 2 comma something. Alright, 7 is asking for the horizontal asymptote. I have 0 x's on top. So it's going to just be y equals 0. And then 8 is asking for the zeros. If I factor the top, I can take out a 3, and I'm left with x plus 4. On the bottom, if I factor, I have x plus 4 times x minus 1. So the x plus 4 actually gets canceled out. And my equation I'm looking at is 3 over x minus 1. It doesn't make any sense for me to set 3 equal to 0, so I'm not going to have any zeros for that problem. Alright, now let's get into the notes for today. The only new thing that's going to start to happen today that we haven't seen before is that we will have a couple of problems where we cross the horizontal asymptote. Everything else we're going to start just like before. So the first thing I'm going to do on number 1 is I'm going to factor my denominator. This one's going to factor to x minus 6, x plus 2. Nothing is going to cancel, so I'm not going to have any wholes for this one. I am going to have two vertical asymptotes, x equals 6 and x equals -2. I'll go ahead and put those on my graph right away. Okay, for the horizontal asymptotes, this is where I'm looking at the degrees. The degree on the top is smaller than the degree on the bottom. I only have x to the first on the top and I have x squared on the bottom. So if the degree on the top is smaller, my horizontal asymptote is y equals 0. Okay, for my zeros, I'm going to set the numerator equal to 0, which is going to give me 0. So 0, 0 is actually going to be my x-intercept and my y-intercept. Okay, now I'll go ahead and make an xy chart. I'm going to put my vertical asymptotes in the middle. If you plug in -3 on your calculator, you're going to get -0.33. When I plug in -1, I get 0.142. So I'll go ahead and put those points on my graph. And then on the other asymptote with 6, I'm going to choose 7 and 5 to be my points. If I plug in 5, I get -0.714. And plugging in 7, I get 0.77. So again, if I plot these, that's what I'm looking at. Alright, so now, whenever I'm connecting my graph, I want to start with my outside regions. The region out here and the region out here, and that will dictate to me what's going to happen in the middle region. So, on the outside regions, I can see I have a point down here, so my hyperbola is going to be in the lower left, and a point up here means I'm going to be in the upper right. And since my graphs are in the opposite regions, I know that in between I'm going to have that S shape, where my arrows go away from each other, but still towards the asymptotes. Alright, let's try number 2. First thing again I'm going to do is factor. So this one, if I factor the denominator, I've got x plus 4 on top, x minus 2, and x plus 2 on the bottom. That means nothing's going to cancel out, so no holes. I have two vertical asymptotes, x equals 2 and x equals -2. I'll go ahead and put those on my graph. Okay, for horizontal asymptote, again I'm looking at degrees. Because I have fewer x's on the top and more x's on the bottom, that means that I'm going to have y equals 0 again. Okay, zeros, if I set the top equal to 0, I'm going to get -4. Now, this is what I mean by when you're crossing the horizontal asymptote, it will be obvious. I have a horizontal asymptote here at 0. I also have a point that is right on that line. I'm never going to have you cross the horizontal asymptote and make it way out here. It's something that you wouldn't even know about. It's always going to be pretty obvious just doing your regular work. Okay, for the y-intercept, we'll plug in 0 for x, and we'll end up with 4 over -4, which reduces to -1. Okay, and now we just have to do our xy chart, and then we'll see what this graph looks like. So I'm going to do my xy chart up here. We've got -2 as an asymptote, so I'll choose -3 and -1. If I plug in -3, I get 0.2. If I plug in -1, I get 1. And then if I plug in the numbers around +2, I'm going to choose 1 and 3. When you plug in 1, you get -1.6, and when you plug in 3, you get 1.4. Okay, so I'll go ahead and plot those points. Okay, now, it's a little bit hard to tell with that point that's crossing the asymptote, so I'm going to choose a couple of other points just to show you what happens. We know that at -4 we're at 0, And if I plugged in -5, I would be at -0.04. So I'd be very close to that asymptote, just a little bit below it. So what's actually going to happen with your graph is you're going to have it be a hyperbola up here, crossing the horizontal asymptote right there, but still hugging it very close. My other hyperbola branch is also going to be in this upper region over here, but it doesn't cross. So it doesn't have to be symmetrical in the fact that if one side crosses, the other side doesn't have to cross. And if I have both regions in the upper part, then in the middle, I'm going to have a parabola shape that opens down. So the big thing to just notice here is that this is a point where I cross the horizontal asymptote. It's not going to happen often, but it may happen sometimes. Alright, we've got one more to look at today. So let me start by factoring. On the top, this is going to factor x minus 2 times x plus 1. On the bottom, we've got x plus 4 and x minus 2. So this time I do have something that cancels. The x minus 2's are going to cancel, and the equation that I'm left with is x plus 1 over x plus 4. Alright, since something canceled out, we are going to have a whole, so I'm going to set that eliminated part equal to 0, which means my whole is going to be at 2 comma something. I get the something by plugging 2 into my new equation. So if I plug in 2, I've got 2 plus 1 over 2 plus 4. 3 over 6 tells me I have a whole at 2 comma 1/2. I'll go ahead and put that on my graph right away. Okay, now let's go on to vertical asymptotes. I'm going to have a vertical asymptote at x equals -4, because that's what makes my denominator 0. I'm going to have a horizontal asymptote at y equals 1. These are the same degree this time. They're both x to the first, so I'm using the ratio of their coefficients. I have one x on top and one x on the bottom. Okay, for my zeros, I set the top equal to 0. So if x plus 1 equals 0, I get x equals -1. Okay, and then for the y-intercept, I plug in 0 for x. 0 plus 1 over 0 plus 4 is 1/4. Okay, now I already have a pretty good idea that my graph is going to happen in this lower region down here, so I'm suspecting my other portion will be up here, but let me do an XY chart just to be sure. So I'm going to put my asymptote at -4 in the middle. I'm going to choose -5 and -3. When I plug in -5, I get 4, and when I plug in -3, I get -2. So if I plot that, it is just like I was expecting in the regions I was hoping it would be. So now I'll just go ahead and connect my hyperbola up here and one in the diagonal region down here. Make sure that you pick up your pencil around your hole. Alright, so very similar to what we were doing yesterday, just a refresher. Think about how to find each thing. If you get stuck, look back at your notes for how to find a vertical asymptote, horizontal asymptote, zeros, y-intercept, or whole. We'll talk about worksheet 2 and worksheet 3 next time I see you on Tuesday. Have a great weekend.